Hello, JB. I just watched your video on, or not on, but asking, why is the speed of light the speed of light? And you said, out of all your subscribers, maybe one of them could explain it to you. I think I might just be the guy, and hopefully I can say it in a clear enough manner that you will understand, or at least begin to consider why maybe this is why it is. And for my explanation, you're going to have to understand the Pythagorean theorem, which you probably do. I mean, everyone learns it in basic math, in that a squared equals one side plus another side of a right triangle equals the third side with squared, root squared. It makes sense. But something that you have to think about is that the Pythagorean theorem doesn't just work for two-dimensional triangles. If you take a line and put it in 3 dimensions, just at some weird angle, any weird angle, you can define it as a horizontal or an x direction line plus a y direction line plus a z direction line and end up at that point, which is kind of the basis of 3-dimensional vectors. So if you've done vectors, I'm boring you. Basically, picture vectors. But the thing is, it doesn't just work in 2 dimensions and 3 dimensions. It works in many dimensions. It works in 4 dimensions, which is what's important. It works in, a trillion dimensions, but nobody cares about a trillion dimensions because nobody does anything with a trillion dimensions because there's not a trillion dimensions. During recent theory, there are 12. But the point is, 4 dimensions, line, it works. The Pythagorean theorem works. So, picture, for example, time. When we talk about time, we say we're moving forward in time, right? I mean, obviously moving backwards in time or forward in time is, what sci-fi is about, but as we live our lives, we're moving forwards in time. But as you think about moving forwards on, in space, in, forwards and up and left and right, there's a speed to it. We have a speed as we move. The thing is, you also have a speed in time, which is, crazy. But the thing is, the speed in time, at least according to the theories we're doing, I'm going back in my chair. I'm sorry if that made you dizzy. I'll attempt not to do that. But our speed traveling through time, when we're standing still in space, is the speed of light, is what we call the speed of light. Which is kind of difficult, given that we tend to define speed as distance over time, but it turns out that's kind of wrong. I mean, that was what Newton thought, but Newton didn't look at Jupiter very closely, and Einstein said he was sort of wrong. The point is that we're moving in time as much as just as really as we are moving in space. And as you move in space, so the best way to picture this is that you're in a car. You're traveling at 100 miles an hour for a nice round number. And obviously you wouldn't go 100 miles an hour because that's illegal in most places, but you're traveling 100 miles an hour due north. And as you're going 100 miles an hour due north, if someone were to ask you, how fast north are you going, you'd say 100 miles an hour. But if they said, how fast west are you going, you'd say 0 miles an hour. I'm not going west, I'm going straight north. If your car were to begin turning towards northwest, then your speed going north would be slightly less. On your speedometer in your car, you're going 100 miles an hour. But if someone were to be looking two-dimensionally at your traveling north, you're going less than that. You're going less than 100 miles an hour north, and you're also going less than 100 miles an hour west, but you're going more than you were before because you were going north and you weren't going at all west. But that's not important. So, as you turn towards west, away from north, you begin traveling less northwards, if that makes sense. I mean, obviously, that's just normal physics. But picture, for example, is that the speed of light is the speed we are all going all the time. And as we begin to travel in space, we kind of turn our arrow of travel away from time. The faster you go, moving horizontally or forward, time actually, you travel less in time. And that's just, crazy. I mean, if you go fast enough, time actually slows down for you, or you slow down to time, but I can't get my frame of reference right because it's really hard to think about, because we don't really picture things in 4 dimensions, because we live in 3 dimensions, or we live in 3 real dimensions, and I'm not going to get into the imaginariness of the 4th dimension because I don't want to talk about that right now. But anyways, when you accelerate in space, when you get in your car and you begin driving at however many miles an hour, your arrow isn't actually accelerating or decelerating. You're not going any faster or slower. You're simply turning your arrow of travel away from time and towards westwards or northwards. So if you were to begin traveling really, really fast, 0.7 the speed of light, your arrow begins to bend, further and further away from time. You begin traveling less in time and more in space. And that's just crazy. And there's all this stuff about infinite energy, which, again, isn't important. But the thing is, matter can't travel faster than the speed of time, or the speed of light. It's like intervals is what the actual name of it is. But a matter can't travel faster than the speed of light because it's already traveling at exactly the speed of light. If you were to get in a rocket and just start going super, super fast, then, your arrow would begin turning away from time, but it can't ever go farther than that. I mean, once you're no longer moving in time at all, when you accelerate, you're not actually accelerating, which I said before, but you're just moving faster in space than you are in time, and once you reach completely horizontal, which obviously you can't do because you're not made of light. If you're made of light, you could travel at the speed of light, because it takes like infinite energy to travel at the speed of light, which is crazy and demented. But as you're traveling exactly at the speed of light, you can't accelerate any faster. You aren't moving in time anymore, and your arrow is already pointed completely forward or in space, and it's just mind-boggling how this works, but that's how it is. In that matter can't go faster than the speed of light because it's already going at the speed of light. You can't go faster than the speed of light in time, you can't go faster than the speed of light in space, but you can't go slower than it either. And that's just what we're all doing all the time. Right now, as you're watching this video, you're traveling at the speed of light. So if that can give you some philosophy or religion, go for it. So hopefully, amongst all that rambling, you got some useful pieces of information. I suck at video editing, so this is what the form of it's going to be, and I should probably just end this video now, so it isn't super long. And, oh yes, so good to hear about the album. Good luck on that. Glad to hear it's happening. I'm so gonna buy it because I don't know, whatever. I feel like a lot of my gesticulation, a lot of my arm movement is over here. It's been happening off screen, and I hope that isn't too weird. I feel like Hank in early 2007. Maybe I shouldn't. I tend to emulate the mannerisms of people I see. That has nothing to do with anything. I should end this video right now before I make a complete fool of myself. A complete video of myself. Yes, this is a complete video of myself, where I can make a complete fool of myself. So, ending comments, conclusion to the video, speed of light, read everything done by Einstein, look on Wikipedia about intervals and the speed of light and the rules of spontaneity. It's kind of crazy. This is why science is cool. See you around.